So I was curious to know how mathematicians define the word infinite. So I asked a question, and it turns out that they define infinite as not finite. So I prepared a presentation and I'm reading from there. What is the definition of infinite in mathematics? Mathematicians define infinite as not finite. Infinite is not finite. And this must be one of many definitions of infinite in mathematics. I see some problems with definition of infinite by finite. When we define the word infinite as not finite, what does this definition tell us about the word infinite? It seems that it doesn't say anything about infinite. But is infinite a mathematical object? Mathematicians assume before defining infinite that infinite is a mathematical object. But the definition infinite is not finite does not say that infinite is a mathematical object. It just says infinite is not finite. We don't know if infinite has any relation to numbers. We don't know if it has mathematical properties. So far, infinite is a word we know nothing about because it's undefined. We also note that a word is not its meaning. It's not clear if mathematicians are defining the word infinite or the concept of infinite. And infinite is not finite is not a definition. We observe that the statement infinite is not finite is not a definition. Infinite and not finite are the same word. Infinite uses the Latin negation prefix in to negate finite. Not finite uses the English negation word not to negate finite. So we negate the word finite first with Latin negation prefix and then with English negation word not. So these are the same words. Infinite and not finite are the same word, written with different negation words. In this case, not and in have the same meaning and they can be used interchangeably. So since infinite and finite are the same word, we end up with a tautology. Therefore, the statement infinite is not finite is equivalent to the statement not finite is not finite. This is a tautology. The statement not finite is not finite is tautology, and it's trivially true, and it's not a useful definition of infinite. But let's play along and assume that infinite and not infinite are not two different words, are not the same word, and they are two different words, and that infinite is not finite is a good definition of infinite. In this case, we need to know what finite means because we define infinite by using the word finite. To make sense of the definition infinite is not finite, we need to know the definition of finite. This is obvious. Unless we first define the word finite, the statement infinite is not finite will not make sense. I define finite as closed. The word finite means closed. When we use finite with a subject, we state that the subject has an end, or it is closed, or equivalently, one of its elements is defined as the last element. This is what finite means. Finite is closed, not finite is not closed, is open. If we don't see the end, we may call this state endless. There's no end. Endless simply means has not yet ended, or that we don't know when it will end. There's no reason to load the words like endless and infinite with metaphysical properties. Since in mathematics we deal with numbers, we need to define the word finite in terms of numbers. To create new numbers, we add one unit to the last number on the stack. I say stack, not set, as mathematicians usually use set. I use stack. We have a stack of units. This is a stack of units to which we add units to make new numbers. Then we count the units in the stack, and that will be our number. The stack is the number because we count the units in the stack. And the stack is not physical. Since it's not physical, we can add to it as many units as we want. It will never fill up. I think this confuses mathematicians. They think this is infinite. No, we only add indefinitely. We can add units indefinitely, not infinitely. Finite also means we have defined a last number. We stopped. Finite means that we decided to stop adding units to the stack, and we defined a final number. Not finite means that we have not defined a last number yet. So we don't have a final last number. The process of adding units to the stack is still continuing. We always have a last number because we have to add a unit to the last number to get a new number. But none of those last numbers are final last number or stopping number. They are temporary. We add a unit to them and make a new number. Infinite is not finite, gives no information about infinity. So the definition infinite is not finite just says that infinite is not finite. Doesn't say anything else. It doesn't say anything about the properties of infinite, if there is such thing. It says nothing. We keep adding the units to the stack, not to the number, to the stack, until we decide to stop. When we stop adding numbers, when we stop adding units to the stack, we define the last number as the stopping number. During this process of adding units to the stack, we never enter into a state called infinite. We never enter something called infinite. Never happens. Because infinite is not a mathematical object. It's nothing more than a name we gave to not finite. And the stack is the number. When we stop adding units to the stack, the number we stopped at becomes the last number because we count the units in the stack. The stack never gets infinite. As we keep adding units, the stack gets bigger and bigger, but it never gets infinite. The stack gets arbitrarily big, but it will never attain a mystical state called infinite. And infinity is a mystical state, Platonic state. It will always remain finite. The stack will always remain finite because there will always be a last number. And numbers exist only when we name them. There are no numbers outside or beyond the stack because the stack is the number. Numbers exist only when we name them. Numbers are not mystical qualities. Numbers do not live in a Platonic realm. Numbers don't exist except when we name them. Most mathematicians are Platonists, and following Cantor, they believe that numbers live in a Platonic realm called the infinite. And Platonic mysticism, to talk about natural numbers as being infinite, is Platonic mysticism. I believe that. We define the word infinite as the name of not finite. All we know is that infinite is a placeholder for not finite. We don't know anything else about infinite. Infinite is a name and a label and nothing else, and therefore it has no properties. If we need to attribute properties to the word infinite, we need to use a different definition than infinite is not finite. We can make as many natural numbers as we wish, but this does not mean that natural numbers are endless or infinite. We make the numbers. Mathematicians make the numbers. We cannot make an infinite collection of natural numbers by adding more units to the stack. There is always a last number. The fact that we can add units to the stack indefinitely is wrongly interpreted by mathematicians as the proof of infinity of numbers. All natural numbers do not constitute a collection. There is no such thing as all natural numbers. There is no collection containing all natural numbers. All collections are finite. There is no three-dot infinity. Mathematicians put three dots at the end of a collection and say that's the infinity. So it's absurd and funny. We can make a collection only with a finite number of natural numbers that we define. We define the numbers. If we make natural numbers by adding one unit to the last number, then there can only be a finite number of natural numbers. Finite number of natural numbers. Yes, numbers exist only when we name them. We cannot name all members of an endless collection. Therefore, there cannot be an endless collection. But starting with Cantor, mathematicians reified the name infinite and loaded it with metaphysical notions that do not belong to mathematics. I am a finitist. As a finitist, I don't accept Cantor's hallucinations about infinite as a proper mathematical subject. Well, that's not popular, but in the 19th century, especially Kronecker was a finitist, and that was a popular stand, and I think that's the right stand.